AgentRail is a policy firewall for AI agent finance. The core problem is simple: AI agents can propose financial actions quickly, but they should not freely move user funds. Prompts, front-end checks, and trusted backends are not enough as financial safety boundaries. AgentRail turns this into a policy-gated flow. The agent can propose an action, but policy decides before execution, and receipts prove what happened afterward. This demo is a local B-lite MVP, using mock-up pool, not real EV, and not full AG 4337. This dashboard is the demo console. It summarizes the SmartAccount, the active policy, quota usage, recent agent attempts, and latest receipt outcomes. The 4 demo paths are the core of AgentRail: legal execution, policy denial, external mock failure, and circuit breaker pause. Each path shows a different life cycle result, and each result becomes auditable through receipts. Here, the user defines the agent's boundary. The policy controls which asset, adapter, action, amount, and daily limit the agent path may use. In this MVP, the agent can only propose a restricted mock USDC supply style action through EV supply adapter. The adapter is not a fund custodian, it builds restricted call specs. Policy hash and version are important because old receipts remain bound to the policy rules that were active when the action happened. These front-end controls are fixture interactions. The contract behavior is demonstrated by the local Foundry tests and demo script. This page shows what the agent actually submits. The agent submits a signed intent, not raw call data. The signed fields bind the policy version, adapter, external target, asset, amount, receiver, nonce, deadline, simulation hash, and metadata hash. This makes the action inspectable before it reaches execution. The backend and relayer are not trusted for safety. They can relay a signed intent, but they cannot safely rewrite the amount, receiver, target, or other signed fields without breaking the signature. This is the key idea: the agent proposes, the backend transports, but the on-chain policy boundary decides. Now we run the signed intent through the execution pipeline. In the legal path, the policy allows the asset, adapter, action, and amount. The pipeline verifies the signed intent, checks policy, validates adapter call specs, and only then the SmartAccount executes. Funds move only after policy approval, and the result is approved plus executed. In the denied path, the intent is authenticated, but the amount exceeds the per transaction limit. Policy returns denied with amount _exceeds _per _tx limit. There is no adapter call, no module execution, and no fund movement. In the failed path, policy approves the action, but the downstream mock-up pool call fails. AgentRail records approved plus failed, emits no executed receipt, consumes the nonce, and leaves quota unchanged. The pause path shows the circuit breaker. Repeated authenticated denials trigger a paused receipt. After that, even a normally valid agent action returns policy _paused. The important boundary is that AgentRail protects the agent path, not the owner path. Owner withdrawal remains available, and owner key compromise is outside the scope of this MVP. The Receipt Explorer is where the life cycle becomes auditable. Receipts are chain events, not backend logs. A reviewer can filter approved, executed, denied, failed, and paused outcomes, inspect the life cycle timeline, and see how each receipt binds to an intent, policy, action, and effect. The front end is only an explorer, the trusted root is the receipt registry event path. This security page is deliberately explicit about scope. AgentRail protects the agent path before funds move. The front end, backend, relayer, and off-chain simulation are not trusted for safety. This demo uses mock-up pool, not real EV. It is a B-lite MVP, not full AG 4337, and it does not claim production custody. What it does demonstrate is the core safety boundary: agents can propose, policy decides, and receipts prove each life cycle outcome.